So hello, my name is Naveen Patwari, and in this video I'll show you how I ran the JDE robot exercise on my local host. So first of all, as the installation guide says that you need to pull the container from the Docker of the JDE robot. So here I have already pulled the Docker container from the Docker, and I can run it. Like I can start it, and yeah, it shows that it is running on this local host. And now I can turn my Docker to run the Robotics Academy on my local host. They have given this line of code on the website itself, which makes it really easy for installation and running the exercises. And so, yeah, when we run this exercise, you can see that there is something which has started over here. And when I go to the local host from this site, here it is loading exercises, and it has loaded the exercises in the local host 8000 port. And so I will just go to the follow line, and you can see that it's trying to connect. So yeah, we have got this green signal that it is connected, and this waiting signal that we should wait for launching of the code, like connecting it to the backend. And yeah, so the connection is established, and we are ready to move forward with the code. I have copied the Python code in my clipboard, and you can see that this is a pretty simple code where I have used the advantage of the red color of the central line. Ideally, it will be much better if I would have gone through the other parts, like other methods which have been given over here, like the detection of line flow and all these. I don't know why this Stack Overflow refused to connect, but here you can find it. Like there are methods which are given over here, and yeah, so we can run this code, load it in robot. The code is really simple. Like I have kept the vertical, like not the vertical, the velocity constant. Like said, v is one at every instant, and angular velocity as well is like not constant. It's just for following up with following up, trying to reduce the oscillations as much as possible. I don't know why is it not working. Just let me refresh it once. Um, and the reason why I haven't kept the speed to a higher number is because of the oscillations which are caused. My code is not that that much expert in handling the oscillations which occur while following the line, and thus it crashes. So I wanted to complete this exercise, and that's why I chose to go for this slower speed. And as you can see that it's trying to move in the straight line, and in fact it is moving the straight line. And you can also check out my terminal, like where everything is going on. Like it is written that run a simulation, which is working fine. And we can view the simulation over here. Gazebo is working. Shows connected. Here you will be able to see a 3D image that will be rendered. You can see that our model, the car, is moving in this straight line, and you can toggle it like as per your needs, like wherever you feel that you should. Uh, Maybe we can increase the speed a little bit so that like it's way too slow. So I can increase it a bit and show you like how does it react to that. Ideally, I should have paused and reset it, but I don't know. Like in because I felt some urgency, then I just overrode it in the load robot. But anyways, the developers have kept it in the mind that this may be the case, and as you can see that since I have increased the speed, there is some fluctuation going on, and it is this fluctuation which I am unable to handle properly at the moment. And although I have tried a bit, but still I'm not that much familiar the with achieving these goals using CV. I have rather tried deep learning, and I think that the deep learning approaches maybe even well suited for these. And also like of course reinforcement learning, which I think that should work. But yeah, I understand the main goal is to be get oriented towards the deep learning. And so yeah, you can see the console over here, and if you want to write anything in the console, you can just print over here, and it will be just printed out in the console. Let's say that you want to print the error. Let's see this D difference. So you can just go for print D, and again reset. Load this in robot, and so yeah, here you can see that like output is already started generate. Already output is there, and we can just play it. Like we have already reset it, right? So it will start from the beginning, and you can see this. And simulation, I guess it will be okay in a few minutes. You can see over here that console is being updated every time interval, and yeah, so that is the implementation. I would like to go till the curve where the oscillation is much more, just to visualize it. Like yeah, it is able to oscillate, so that you can see that yeah, it is able to oscillate. I would like to leave it till the curvature comes into the picture. And so here you can see that it has already started oscillating a little bit. Just trying to keep up with the line. I hope that line does not go out, but because like my code is not will not be able to handle if the red color is missing. So I just hope that it won't go away. Please, likely. Yeah. So you can see that it has handled to keep in with the red line through the oscillations and trying to damp the oscillation. And yeah, that is pretty much it for the video. Thank you.